For the first one, 648, I mean, maybe you don't know off the top of your head. And when that happens, you got to do something. So in your calculator, you go to y equals, let me get rid of this stuff, and just type in x squared. All right, then you go to your table, and now you have a list of perfect squares in the y1 column. So I always start off with half of whatever the numerical value is in the radicand. So half of 648 would be 324. So I'm going to start looking in that neighborhood. And if you're really lucky, it'll turn out that that half value is itself a perfect square. So you're in pretty good shape, because I now know that the best possible factors in this context of 648 would be rad 324 and rad 2. All right. So the rad 324 is 18. It says it right here. It's the benefit of having this list. So 18 radical 2. We still have that 5. So 5 multiplied by 18. Right? So we're looking at 90 radical 2. All right. So we just do the same thing with number 2, but we also have that added component. It says simplify and rationalize each radical expression. All right. The first one, if we wrote this as 90 radical 2 over 1, we would have the radical contained strictly in one part of the fraction. All right. So that's rational or rationalized in terms of the denominator. All right. This one has a rational numerator, so it's rationalized already. It's just a question of, can I simplify that rad 294? So I go into my list, I look for half of 294. Right? Maybe you can figure that out in your head, maybe not. But, you know, if you figure it's close to 300, but a little lower, half of 300 is 150, so go a little lower than that. So I'd be looking in the neighborhood of 144. So any of these values would be candidates, right? Maybe even lower, right? So I would look at, and you know, it's tedious, but I would look for the ones that are factorable by or into that 294. So I get out of here, I say 294 divided by 144. No dice. All right. By 121. So 294 divided by 121, no dice. And you keep going. It's not going to be divisible by 100. So you try 81. No dice. And this is one of those instances where, you know, you get a little further down the line, you start thinking, well, maybe I should have worked my way up the line. It's just, sometimes it plays out that way. 294. But it's almost always in your best interest to start high and work your way low. So 49. And then at long last, I get the 6. All right? So I know 6 and 49 will divide or multiply. They'll multiply to 294. They'll both divide evenly into 294. So radical 49, radical 6. So that becomes 7 rad 6, or 7 rad 6, not 7 rad 7. All right, so this expression is now a replacement for the rad 294. So I would write this as 3 over 7 radical 6. All right. Now, I've been trying to keep it simple with the calculator techniques and things of that nature. It's just, you know, sometimes too much too fast can be, well, too much too fast is probably the definition of overwhelming. So I've been kind of staying away from this, but I mean, that what we just did there was pretty tedious. If I'm looking for a value in y1 that's divisible or that divides evenly into whatever the radicand is, as a separate step in my calculator, I could take 294 and divide it by whatever I have in y1, right? So if I do 294 divided by alpha trace y1, I'll get a new column that consists of all the values that you would get if you took 294 and divided it by any of the entries in y1, right? So if I go to my table, I'd go into y2 and just look for any instance in which there's a whole number. But I'm looking for the largest instance, right? So I take a look, at least until I get to 294, so I kind of went overboard. But once you're at the neighborhood of 294 and you've only seen one, maybe two whole number values, then whichever one of those is bigger is the one that you take. So in this case, I got a whole number. That's telling me that these two numbers together, 49 and 6, will multiply to 294, right? So I'd have my factors that way, right? So again, in your y equals menu, you're just doing x squared like we normally would, and then whatever the radicand is divided by whatever's in y1, right? So I could have done that for the first question, 648 divided by y1, go into the table. See, I got a whole number here, but I also have a whole number here. All right, if I keep going down the line, I got another whole number. All right, I want the one that corresponds with the largest y1 value. All right, if I keep going, I won't get any more whole numbers. So that 324 was my winner. But now I would know 324 times 2 is equal to 648, and also, since 324 is in my list of perfect squares, I know that that's going to be a perfect square factor. All right. So like in the next one, 275, the only adjustment I would make is to change my 648 to 275. Now this one's probably a little easier because, you know, it's got a 75 in it, so odds are 25 is going to be one of the factors. But, you know, we have this technique. You go up the list, starting, well, really down the list, starting with the half value of 275, which is going to be in the neighborhood of 140 to 150. So right around here. Then I start working my way down, looking for whole numbers in the y2 column. So 25 and 11. Oops. 25 and 11 will get the job done. All right, so I'd look at this and say, all right, well, if I pull this out, make it its own problem. Rad 275, that's equivalent, you know, like side work. We have 25 and 11. Those are my winners. I'm looking at 5 radical 11. That 5 radical 11 replaces the 275, rad 275. So I'm looking at 2 times 5 radical 11 over 15. Could simplify a little bit because 5 and 15 are both divisible by 5. So I could divide each one of those by 5 and get a 1 here, a 3 here. So now I'm looking at 2 times 1, which is 2 radical 11 over 3. And this one's rational, right? At least in terms of the denominator. Yeah.
When you were doing the like 249 divided by y equals, how did you get the divided by y1 option?
Alpha, trace, then y1 will be the first option.
Thank you. So when I did this, I did 2 times 5 is 10, so I did 10 radical 11 over 15, and then I simplified it from there. Would that be okay to do it like that?
Yeah.
Okay.
Yeah, that's equivalent. Perfectly fine. So then we get to the completing the square problems. This one was just asking you to find the C value and then factor. All right, so it's kind of like the C is taking on the role of the little space that we would leave when we would complete the square. So I'm looking for the perfect value of C that would make this a perfect square trinomial. All right, so I'll do my side work, which in this case is really most of the work. Take my B value, cut it in half, square it, and I'm going to get an 81 that way. All right. because the b value was the negative 18. You cut it in half, you get a negative 9, but when you square any negatives, it becomes positive, so negative 9 squared becomes 81. All right, so that would be the value of c that I would want. All right, so x squared minus 18x plus 81. Then to factor it, we know it's going to be a binomial squared, so we take the square root of the first term, we take the square root of the last term, and we carry down the sign of the middle term. So we're looking at x, a 9, and a minus to separate them. That's all this question was asking you to do. All right, these questions anyway. So number 5, same deal, except now you'll get a fraction in your side work, but that's not a big deal. So take my b value, cut it in half, square it. (11/2) would be a decimal value, so we'll leave it as a fraction. Whenever you square a fraction, you square the top, and then you square the bottom, then you piece it back together. So 11 squared is 121. 2 squared is 4. All right. So my new trinomial is going to be x squared plus 11x plus 121/4. Factoring that, again, binomial squared, we're going to take the square root of the first term, we're going to take the square root of the last term, and we're going to carry down the sign of the middle term. All right. So the square root of x squared is x. Square root of 121, we find the roots the same way, or using the same principle as raising it to a power. We're just going the other way. So we take the square root of the top number, we take the square root of the bottom number, and we piece it back together. So that's going to give you an 11/2. But if you really think about it, that should not be something that you would have to compute. Because if you really think about it, looking at what we did over here, we took 11/2 and squared it. And that became 121/4. That's the number that got put in as a c value. If 11/2 squared is 121/4, then the square root of 121/4 would be 11/2. So if I went to find the square root of this, the result would be that, right? And that's because it's the exact opposite operation, right? If I said 4 squared is equal to what? You would say 16, and then I turned around and said, okay, now what's the square root of 16? You'd be right in looking at me being like, didn't you just kind of ask that? It's 4, because you told us to square the 4, and that gave us the 16. So going the other way should just give you what you started with, right? That's what's happening here, right? Then the remaining problems have us go in the distance, right? So we vacate the c value by adding it to both sides. So add the 16. You're going to get x squared plus 6x is equal to 16. And then you do your side work. More and more of you should be at the point, well, I don't want to put a percentage on it, but should be getting better at doing the side work in your head. All right? Because if I say, what is the b value? 6. What do I get if I cut it in half? 3. What do I get if I square that? 9. You should get there pretty quickly. All right? It's still okay to show the work, but the whole point behind this process is to get it so that it becomes more of a mental step. All right, so I take my 6, divide it by 2, square it, and I get a 9. So I'm adding the 9 to both sides. On the left, we have our factors. Again, something that you should be moving towards doing in your head rather than just kind of rethinking or reinventing the process every time. Square root of the first term, square root of the last term, carry down the sign in the middle term. So x plus 3. We got a 25 here. I'm going to take the square root of both sides. And that's going to give me, well, That didn't look so good. That's going to give me an x plus 3 is equal to plus or minus 5. And then I have to go the distance. All right. So I'm going to subtract the 3, and I'll get x is equal to negative 3 plus or minus 5. Another step that you should try to do in your head. You shouldn't really go for the calculator on this. I mean, if you have decimals and stuff like that, then of course, just play it safe. But and really, you shouldn't have decimals. If anything, it should be in fraction form. But still, like, you're confident that you can do it by hand. You're confident that you can do it in your head, but you don't want to take chances. So you get the calculator involved. That's fine. This is not one of those types of problems. Negative 3 minus 5, negative 8. Negative 3 plus 5, positive 2. All right. It's only the rational cases where you have to go the distance and split it up into two separate equations with the or symbol. If it's irrational, meaning there's a radical in there that you just can't get rid of, then you're looking at something that would be a little simpler, because you would be able to stop in this step here. All right. So looking at the next one, add the 14 to both sides. You get x squared minus 2x equals 14. Take the b value, cut it in half, and square it. Negative 2 cut in half is negative 1. But it won't matter, because when you square the negative 1, it becomes a positive 1. So add 1 to both sides. Factor the left-hand side. Simplify the right-hand side. You're looking at x minus 1. Take the root. Rad 15 is not something that can be simplified. So x minus 1 is equal to plus or minus rad 15. Then I add 1 to both sides, and I get x is equal to 1 plus or minus rad 15. All right. So much less writing, a little more thinking, but that leads to less work. So that's why I'm encouraging you to try to do some of those steps in your head. All right. Number 8, it's already in the appropriate form for completing the square, which is nice. I'm going to take my b value, I'm going to cut it in half and square it, which means that I'm adding 36 to both sides. So m squared minus 12m plus 36 is equal to 10. M minus 6 squared is equal to the radical 10, not radical yet, is equal to 10. Square root both sides. You get m minus 6 is equal to plus or minus rad 10. Add 6 to both sides and you get your answer, because rad 10 is not something that can be simplified. So the process goes quicker and quicker the more you can do behind the scenes. Number 9, we have a leading coefficient. Whenever you have a leading coefficient, among your first steps should be to divide every term by whatever the leading coefficient is. All right. So in this case, it's 6. So I'm going to get b squared minus 2b minus 8 is equal to 0. I'm going to add the 8 to both sides. B squared minus 2b equals 8. I'm going to take my b value, negative 2. I'm going to cut it in half, negative 1. Square it, positive 1. Add that to both sides. So b minus 1 squared is equal to 9. Root both sides. B minus 1 is equal to plus or minus 3. Add the 1 to both sides. And then get your two separate answers. All right, so b is going to equal negative 2, or b is equal to 4. All right. The next two problems are very similar. What I want to do is divide every term by 3. That's going to simplify to c squared plus 10c minus 9 is equal to 2. I only want the variables on the left, so I'm going to add 9 to both sides. So c squared plus 10c, leave a space for completing the square, is going to be equal to 11. I'm going to take my b value, which is 10. I'm going to cut it in half. That's going to make it 5. Then I'm going to square it. 5 squared is 25, so I'm adding 25 to both sides. Left side, square root of the first term, square root of the last term, carried down the sign of the middle term, c plus 5 squared. Right hand side 36. Root both sides. You're looking at c plus 5 is equal to plus or minus 6. All right, but because it's rational, I need my two separate equations, so I subtract a 5 from both sides. I'm looking at c equal to negative 5 plus or minus 6. Negative 5 minus 6 is negative 11. Negative 5 plus 6 is a positive 1. And so those would be my final answers. At some point, you'll start to prefer cases where it's not rational, where you get irrational values, because it's just less work, especially if that radical can't be simplified. All right? So, we all get there at different points, but that's something that you should be on the lookout for. So divide both sides by 2, n squared plus 2n, leave a space for completing the square, is equal to 13. Take my b value, the 2, cut it in half, it becomes a 1, square it, 1 squared is 1, so add 1 to both sides. So n plus 1 squared is equal to 14. Root both sides. N plus 1 is equal to plus or minus rad 14. Then the only thing left would be to subtract a 1 from both sides, a step that you don't really have to show. N would be equal to negative 1 plus or minus rad 14. All right. Rad 14 is not something that can be simplified, so this would be our final answer. Just in terms of the amount of writing that I had to do for this problem compared to number 10, it's even less. So it should be pretty apparent that when you get a radical that can't be simplified, that's like the best case scenario when you're dealing with completing the square.